Hi everyone, this is Satishuli, Department of Civil Engineering. Today we are going to see regarding what are membranes. So membranes are nothing but these are the barriers. Okay, these are have porous in nature. Okay, and which allow feeded water to pass through them. Based on their pore sizes, they retain back the components or the dissolved solids or the suspended solids which are present in water. Based on their pore sizes, the membranes can be divided into micro, ultra, nano and reverse osmosis process. So these are nothing but these are the barriers also. Okay, and they are being divided into mainly of two. What type of force it is being exerted in that process, okay, and what type of membrane materials which are used in separation mechanisms. Okay, next, what is an microfiltration? So microfiltration, here it is nothing but it is made up of an polypropylene or nylon material itself. Okay, and it has got in size, it can remove in particles and biological of size 0.025 micrometer to 1 micrometer in range. Okay, it has a pore size of 0.05 micrometer to 1 micrometer. It can reduce in turbidities, it can remove suspended particles, it can also reduce the bacteria which is being fed into that membrane itself. Okay, now, what do you mean by an ultrafiltration? So ultrafiltration is nothing but it is same as an microfiltration itself. Okay, but here the pore sizes are little bit smaller. It can remove dissolved, can say dissolved solids, okay, of higher molecular weight. And here an hydrostatic force is applied against a semi-permeable membrane. Okay, so suspended solids which has gotten higher molecular weight are being retained back over here. Okay, so it is been same as in reverse osmosis or microfiltration or in nanofiltration, except the size here what it does, it retains a higher size molecular weight. Okay, so of 100 to 1000 molecular weight. And what it happens in ultrafiltration here is it allow the water and salt to pass through them. Okay, so nanofiltration. So nanofiltration, the small sizes are little bit smaller than compared to that of a micro and a nanofiltration. Okay, it can remove ions. Okay, it can remove metallic ions. Okay, which are responsible for hardness. It can remove both organic and inorganic compound. Here the sizes varies from 1 to 10 nanometers. Okay, so nanofiltration, it is has and smaller in size when you compare to a micro and ultrafiltration, but it is larger in size when we compare to an reverse osmosis process. So we are going to see regarding now in reverse osmosis process. Okay, so reverse osmosis process has a very much great advantage when you compare to in depth filtration. So depth filtration here is nothing but it is slow sand filter, rapid sand filter and a pressure filter. You can see that filter media depth there is little bit larger, yeah, in terms of centimeters, say 90 to 110, 60 to 80 centimeters. So when we compare to that, these are very much smaller. So water is passed to an high pressure, and okay, it by that what it the goes there is a deionization process take place. It can remove salts, smaller molecules and lower molecules weight also, so less than 100 ites. Okay, so in this what happens here is it's a partially what's in permeable membrane. Okay, so water has been passed to within certain pressure over there, that is an somatic pressure. Okay, so by doing so what we are doing is we are removing out the impurities. You can see here a semi-permeable membrane, the water is being passed to a higher pressure. Okay, you can see the contaminants are being held back over here. You can see in this figure also the porous sizes, okay, which has lesser than that only they are allowing it to pass, rest of all are retained back. In electrodialysis process, what we do is we use an semi-permeable membrane, and also what we do is we introduce what we can say here is in cast iron and iron ions. Okay, we put in a different charge, and here is an electro, what you can say, uh, ion exchange membrane. Okay, it is nothing but it's an ion exchange membrane, and potential difference is been added over here. Electrical potential difference is been added over here, and it attracts, what you can say, opposite charge. By doing so, what we do is we remove the impurities. Okay, electrodialysis stacks, these are nothing but these are the stacks over here, okay, of positive and negative charges. You can say it's an ion and cash ion. Okay, so by doing so, what we can do is we can remove the impurities. This figure represents of sizes, okay, from lesser to in greater. You can see in which size the various filtration process are lying. Based on that, what they are removing it out. This is taken from SK Garg book, and this is taken from a Metcalfe Eddy book. Okay, so also you can see this is often smaller in size, this is often larger in size, where that filtration process lies with respect to the sizes and what they can remove from that water itself. And this is a difference between an microfiltration and nanofiltration based on certain characteristics. So characteristics are nothing but what type of force given, separation, pore sizes, typical ranges, what they can remove, okay, operation range, operation pressure, rate of flux and all. Okay, so this is a difference. Now what we can see here is an advantage and some of the disadvantage of micro and ultrafiltration. Okay, so here it can remove the chemicals and all. Space required is small, 80 to 50% when you compare it to an depth filtration. It is a less laborious, automatic. You can remove minerals and bacteria. Some of the disadvantage here is it consumes more electricity. Okay, you require some pre-treatment to prevent flocking. Okay, and it has to be these membranes has to be removed with respect to certain intervals. Okay, and those intervals may be of 1 year, 2 year. You need to replace it with a new one, and they are very much costlier one. Okay, and they provide a very much scaling program. Okay, flux rate decline over a period of time due to that scaling itself. Okay, and you need to constantly monitor it. Okay, sometimes they're like in reliability also, they tend to break down very quickly sometimes. Again, you can see some of the advantage and disadvantage of microfiltration and ultrafiltration over here, and also with respect to reverse osmosis filtration. So this is taken from SK Garg book. Sorry, this is taken from a Metcalfe Eddy book. Applications of micro and ultra filtration here is it can be used in industry, chemical industry, paramedical industry, food industry, beverage industry, dairy industry. You can use it. You can use it in blood dialysis also. Okay, of contaminated blood. And these are the some of again application for biological, for an aerobic treatment. Okay, you can use it, and you can see these are the applications where they are being used, like an effluent recycle, effluent disposal, okay, wastewater softening and all. So you can see with respect to ultra and microfiltration over here, with respect to nanofiltration over here, with respect to reverse osmosis filtration over here. So what are the principle? So principle is nothing but what you can say, the pressure exerted for separation, okay, of solvent. Pressure you require to separate those solvent means how much pressure you require to apply on those membranes itself. So that is given by Darcy's equation. So that is J equals to TMP divided by mu RT. So J is nothing but a flex rate. So how much pressure you required. TMP is nothing but transpermeability pressure. Okay. Mu is nothing but solvent viscosity. TR is nothing but total resistance over here. So this is that equation. So now what is membrane flocking? So membrane flocking is nothing but it's a deposition. Okay, it's a potential deposition or accumulation of constituents. So constitution may be an colloidal clay, okay, biological like bacteria, organic like oil, scaling like minerals. So flocking, what it does and problem is it when it happens, it increases the cost. Operation of the plant tend to reduce. Okay, there is a standard blocking here over there. There is a complete blocking. There is a crack formation in those membranes itself, or intermediate blocking is taking place. Blocking can get occur in three types. Okay, so build-up of constituents from feeded water. Okay, a chemical precipitation due to chemistry of means what type of chemicals are present in that feeding water. Okay, so due to that, what happens, there is an damage in those membranes also. And sometimes what happens, there is an biological due to some what you can say bacteria or viruses which are present in them, they can colonize those membranes. So these are the major problems. These are, you can see again, this has been taken from a Metcalfe Eddy book. Okay, so you can see the type of locking and responsible constituents and what they can do it, how they can damage those membranes itself. Okay, so acid also can to damage extreme pH, chlorine, bacteria, free oxygen. These all can damage those membranes. So how to control it? So controlling part, what we need to do is we need to give backwashing continuously. Okay, and again what we are going to do here is some pre-treatment has to be given before you feed the water into the membranes, and some chemical treatment. So when the chemical treatment is being given is when the backwashing, after backwashing, what happens, there is some constituents are remaining back. They cannot be removed by backwashing. So they can be removed by putting some chemical or chemical precipitation, okay, into feeded water, into that water which is being feeded. This is known as a chemical treatment. So when we do it, that time we can remove those impurities, okay, from that membranes. So this is all about membranes. So thank you very much. Stay home, be safe.